All right, welcome to Physics Video 7.5. We are going to learn about methods of charging. In the last video, we learned about electric forces, which depended on the charge of the two objects. So in order to have electric forces, we have to have objects that are charged. So the question is, how do we charge objects? And that is what this video is about. I'm a little apprehensive about this one. There's a lot of information here, and I tried to figure out a way to split this up into two videos, but I couldn't come up with a good breaking point. So buckle in or buckle up. All right, so here we go. Objectives. Some of these were in the last video, so you should know what each of those items are. You should know the difference between a conductor and an insulator. You should understand how to make an atom into an ion. It's called ionization. You should understand how an atom becomes polarized, and you should understand the 3.5 methods of charging. Okay, so here we go. First of all, this is, I think, straight out of the last video. So atoms consist of 3 different types of particles. There are protons, which have a positive charge. You got neutrons that have no charge at all, and electrons have the same amount of charge as a proton, but it's a positive amount or a negative amount. Okay, protons positives, electrons are negative. Please don't make the mistake of thinking neutrons negative, because that is not correct. Neutrons are neutral; they have no charge. All right, so all atoms have an equal number of protons and electrons, and as a result, they have no net charge. The number of protons and electrons that an atom has determines which element it is in the periodic table. So, for example, if you look at the periodic table, right here is carbon, right? Carbon has 6 electrons and 6 protons. Oxygen, 8 electrons, 8 protons. Seaborgium, I'm sure I didn't say that right, has 106 protons and 106 electrons. All right, so how many protons and electrons an atom has determines which element it is. All right, so there you go, chemistry. Now, because we're not going to get into the specifics of how those different elements work, for simplicity, every single atom that I draw in this class, I'm going to draw like this. I'm going to give it, sorry, 4 electrons, 1, 2, 3, 4, and 4 protons. 1, 2, 3, 4. Okay. Now, again, keep in mind, not every atom in the universe is like that. You know, they have different numbers. But in terms of understanding what's happening to the electrons in an atom, when I draw an atom, I'm going to always draw them with 4 protons, 4 electrons. All right. Now, sometimes an atom can gain an electron. All right, and when that happens, it's no longer an atom, it's now called a negative ion. All right, a negative ion is formed when an atom gains an electron. All right, so here's our atom, and some of you are looking at the second drawing and thinking, well, the negative ion is the same. So what happens is this becomes a negative ion if it, oh shoot, gains an electron. Okay, now we have a negative ion. Okay, because we have, gosh, we have 5 electrons, but only 4 protons. So you end up with a net charge of -1, right? All right, so that is how you get a negative ion, is if somehow, and we'll talk about how this happens, if an atom gains an electron, it becomes a negative ion. Okay. Conversely, you can also have positive ions. Positive ions are formed if the object loses an electron. All right. So when you lose an electron, then what you get is that. Okay. So now we've lost an electron, and as a result, now we have sort of 4 positives and 3 negatives for a net of 1 positive, right? So this is now a positive ion. It has more positive than negative. Okay? So that is what is going on there. Hang on one second. Okay, so for shorthand, because this gets a little bit difficult to draw, I am going to sorry. I'm bothered now by the fact that my negative ion is not in fact negative. There we go. Okay, sorry. So because these drawings become a little bit cumbersome and are difficult to draw, if I want to draw an atom for shorthand, if I need to draw a whole bunch of atoms, I'm going to just draw a circle with an A. Okay, that is an atom. All right. Here is an ion. It is, I don't know if you can see it with the red, it's an I with a negative sign in front of it, okay, to indicate it's a negative ion, okay? And then positive ions we'll draw like this with a plus I in it, okay? So atom, negative ion, positive ion, okay, for shorthand. And I tried to color code them so that they would sort of stand out. All right, so now there are different types of materials. All right, there are what are called conductors and what are called insulators. All right, a conductor is a material that allows electrons to flow freely from one atom to another. All right, and the reason that that occurs is because the electrons at the atom's outer shell are attracted to the nucleus by a relatively weak force. All right, so what might happen is that suppose that the lower part of the screen here represents whatever, a piece of metal or something, which is a great example of a conductor. Okay, and you've got all these atoms in it. All right, well, if you somehow take a really strong positive charge, so suppose we had a big positive charge on this side of the conductor. All right, well, remember, oh shoot, I didn't want to do positive. I wanted to do negative. Suppose we had a big negative charge. I guess it wouldn't really matter. Suppose we had a big negative charge on one side of the screen. All right, well, what's going to happen? Remember, like charges repel each other, right? So, for example, this electron right here, when it realizes how close it is to this negative charge, it's going to be repelled. And so what's going to happen is that electron is going to kind of float over to here. All right, and basically what you get is these electrons flowing from one atom to the next, okay? And that's what's actually called electric current, is that the electrons move from one to the other, okay? Notice that as that happens, your atoms are constantly becoming, like here, we were left with, whoa, that's not what I wanted to do. Here, we were left with a positive ion, right? Whereas over here, now we've got a negative ion, right? Okay. But so the big thing that you need to understand there is a conductor allows the electrons to literally move from one atom to another. Okay. Like in this case, this electron had moved from over here, right? So the electrons move from one atom to another. Okay. That is a property only of conductors. Okay. Now, at the other end of the spectrum are what are called insulators. All right, an insulator is a material that does not allow the electrons to flow freely from one atom to another. Okay, and the reason that doesn't happen is because the electrons at those atoms' outer shells are attracted to the nucleus by a really strong force. Okay, remind me in class to give you my childcare analogy here. My daycare analogy, and that'll help give you a visual. So anyway, the idea here is, again, I've got all these atoms drawn on the screen. Each of these electrons has a very tight bond to the nucleus. So this electron here wants to stay with this nucleus. It's not going to move, okay? So because of that, you can create what's called a polarized atom. Okay, a polarized atom is an atom which has an uneven distribution of electrons, creating one side of the atom with more positive charge and another side with more negative charge. Okay, so over here on the left side of the screen, we've got just a regular atom, right? Okay, on the right side of the screen, let's turn this into a polarized atom. All right, and the way this might happen is this. Suppose we once again took a really strong negative charge and brought it close to this side of the atom. All right, well, what's going to happen is this electron here is going to see this negative charge, and it's going to want to get as far away from it as it can, right? So it's going to be pushed away and get pushed over here, okay? This is a bit of an oversimplification, but so then what happens is now we've got an atom that has been what's called polarized. Look, here's our atom. And if you draw a line down the middle, you've got one side of the atom that has more negative and another side of the atom that has more positive. So we've polarized the atom. With that, if you think about like a government body being polarized, it means that half of the body is pro something and the other half is con, right? Same idea here. We've got one half that is negative, con, and one side that is pro, positive, right? Okay, so the atom's now polarized. Notice none of the electrons have actually left the atom. They've just sort of repositioned themselves within the atom, okay? So again, this becomes a little bit cumbersome to draw, so I'm going to use shorthand. So here's an atom that's polarized with the positive on the left. Here's an atom that's polarized with the positive on the right, okay? Probably worth discussing. How do we do that? The atom that I drew up here has the positive on the left. To flip it, how could you do that? Well, you could either put this negative charge on the other side, right? Or it turns out if you make it a positive charge, you get the same effect, right? Think about this. Let's go back to our starting point. All right, before I messed up our atom, it looked like this, right? So what if we had a positive charge? In that case, the negatives would be attracted to it, right? So now my electrons are going to go zoop, zoop. Okay? And so now we've got the negatives on the left and the positives on the right. Okay, again, here's your atom. Draw a line down the middle. You got more negative over here, more positive over here. Okay, so there you go. Polarization, or polarized atom, sorry. Okay, so now that we know all the different things that can happen to an atom, those things being polarization or ionization, we can learn about the methods of charging, which was the whole point of this video, right? How are we doing on time? Look at this. We might keep it under 20 minutes. We'll see. Okay, so first type of charging is what is called charging by contact. All right, this occurs when you've got two conductors with different charges that come into contact with each other. In other words, they touch each other. And when that happens, some of the charge gets transferred from one object to the other. Okay, so in this example, we've got a negatively charged metal plate and an uncharged metal plate. Metal's important here because it's a conductor. Okay, and so what happens is, notice the plate on the left has all these negative ions. It's got all these, some of the atoms have extra electrons, right? Oh, I forgot to color one of my guys. Anyway, so let's make it so that they touch. All right, so remember, all of those little red ions that I drew there are repelled from each other, right? Okay, that's all those extra electrons. And so what happens is, some of these extra electrons that are here are going to get repelled from each other and get pushed over to the other plate. Okay, so these green arrows that I'm drawing here represents electrons moving away from each other. So this green arrow here is an electron moving. Here's an electron moving. Here's an electron moving. So what's going to happen is, for example, this ion here is negative because it has extra electrons. And those extra electrons move from here to here. So this guy basically turns into an atom because it loses the extra electrons it had. And this guy here is going to then become a negative ion because it will have gained an electron. Okay? And so the end result you get is this. Now we have two negatively charged plates, right? Because this guy that had been an ion before lost its electron to this guy. Okay? And so now both of our plates have negative charges in them. Okay? The comment down here at the bottom is really important. Notice that here the electrons actually traveled from one object to the other. They're moving from the atoms in one object into the atoms of the other object. In this case, it's because the extra electrons in the charged plate repel each other, so they move to the uncharged plate. Okay. The same thing would be true if these were positive charges. The only difference is the electrons would move to the positive charges instead of out of the negative charges. Which I guess is something I have not stressed at this point. Only electrons can move, right? Your protons are kind of captured in the nucleus, and they're not going to move unless nuclear physics, unless you split the nucleus, which requires a tremendous amount of energy and is called an atom bomb, or is how you create an atom bomb. Okay, so there you go. That is the first type of charging, contact. Okay, it occurs when two conductors touch each other and pass charge from one to the other. All right. Next type of charging is called charging by friction. All right, this occurs when you've got two uncharged objects and then you rub them together. Okay, if you've all done this where you rub a balloon on your head, it makes your hair stand up. When you rub two objects together, very often electrons from one object get transferred to the other object, leaving you with a positive charged object. The one that lost electrons is now positively charged, and then the other object will be negatively charged because it gained electrons. All right. So what we would do is, right here we've got these two uncharged objects. So if I take this one and kind of rub it against here, doing that would cause the electrons to move from one object to the other. Now, how you know which way the electrons go is a lot of chemistry. We're not really going to get into it. But the point is, when you rub them together, so rub, rub, and what happens is electrons move from one side to the other. Okay? So again, these green arrows represent electrons moving. And so the end result that you get is this, right? I had an electron that moved from here. Whoa, that's not what I wanted to do. Here we go. We had an electron that moved from here to here. We had an electron that moved from here to here. We had an electron that moved, whatever, from here to here, and from here to here, and here to here, and here to here. Notice I ended up with just as many positive ions as I did negative ions. That's because of what's called conservation of charge. We started out with no net charge, and we ended up with no net charge. We've got just as much positive as we do negative. All right, and the comment here is kind of the same. Notice, again, the electrons are actually traveling from one object to the other. They're going from the atoms in the left object into the atoms in the right object. Okay. All right, third method of charging is what's called induction. This is one of the harder ones, I think. Charging by induction occurs as follows. It says if we bring an object with a strong charge near a conductor, we can induce a charge, fancy words, induce a charge in each side of the conductor. And then another way to do it is if you use two conductors that are in contact, then we can give the two conductors opposite charges. All right, so what does all of that mean? Well, check it out. In the middle of the screen here, I've got two uncharged conductors. So they're two metal objects that are touching each other. Okay. Notice they're all atoms, right? There's no ions here. Everything is uncharged. But it turns out that because they're conductors, remember, those electrons are they're happy to move around, right? So if I take a really strong charge, here we've got a really strong negative charge. You can't see it off on the side of the screen over here. It says strong negative charge. Okay, notice it's not quite touching. I did not bring the negative charge over and touch it. I brought it near. Okay, so it's worth noting that it is not touching. Okay, but because of this strong negative charge here, again, the electrons are going to be repelled. So these atoms here see that negative charge, and the electrons there get repelled, and the electrons go boop, 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 and move to over here. And the electrons go boop and move to over here, and move to over here, and move to over here. Okay? And so what you end up with after that is this guy that was an atom has lost an electron. It's going to become a positive ion. That electron has moved over here, creating a negative ion over here. And so afterwards, you get a drawing that looks like this. You've got that strong negative charge. This electron moved to over here. This electron moved to here. This electron moved here. This one moved here, here, and here, right? And then what you can do is separate them, separate the objects, and then take away your negative charge, and now I've got two charged objects. Okay? Now, if I hadn't separated them, and I had removed the strong positive charge that was over here, then the electrons would have gone back to where they were before, right? It was the fact that these electrons were repelled from that negative charge that caused them to separate. All right. So notice here, again, the electrons actually travel from one conductor to the other, and they go from one atom to the other. But the big thing that I want you guys to understand here is this big charge that was over here, this thing, never gained or lost any charge, okay? We used that charge to create opposite charges in other objects, okay? And we're going to be just a little over 20 minutes here. Last type of charging is technically not really even a type of charging. It's very similar to induction, but it doesn't result in charged objects, okay? So we're going to do the same thing. We're going to bring an object with a strong charge near an object. This time it's going to be an insulator instead of a conductor. And what happens is you polarize the atoms, okay? So I'm going to take this large charge and bring it over here again. Once again, not touching. Not touching. It's an exclamation point. All right. And so now what's going to happen is the electrons here want to get as far away as possible from these negative charges. But remember, the electrons aren't free to roam. So if you've got an electron here, all it's going to do is go doop and move to the other side of the atom. Right? Remember where we had this? So positive, 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 negative, 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 negative. Right? So this electron here sees this negative charge, and it's going to kind of want to move to the other side, right? And so what you end up with is polarized atoms. And so now you've got a negative charge here that's attracted to the positive charge on this side of the atom, okay? The biggest thing I want you to notice here is there is no transfer of electrons here. There is not electrons moving from one object to another. There's no electrons moving from one atom to another. It's just that the atoms themselves become polarized as a reaction to this other charge that's brought near it. Okay? So this is a tough concept. So when I see you in class next, we're going to do a lot of cleanup. I'm going to give you guys some examples of it. But this sort of works you through the mechanics of sort of how the different types of charging take place. Okay? So there you go. Methods of charging.